All right, so can everyone hear me now?
Larry, I got confirmation that people can hear you.
Okay, excellent. So got everything working. So I'll go ahead and take it away if that's okay.
That'd be great. Thanks, Larry.
Yeah, no worries. So good afternoon, everyone. I really appreciate you guys taking the time out to talk about drought, the drought status. So today I'll just briefly talk about the water year 2021 drought summary and the current status. And so for those of you who don't know me, my name is Larry O'Neill, and I'm an associate professor at Oregon State University in the College of Earth, Ocean, and Atmospheric Sciences. I'm also the director of the Oregon Climate Services and the state climatologist of Oregon. So today I just want to bring home a couple key points. The first is that the ongoing droughts that we're in, by a variety of metrics, it ranks among the four worst in state recorded history, alongside the barn burners of 1924, 1931, and 1977. And the key drivers of the severity of this drought mainly include the record high temperatures that we experienced over the last, particularly over the summer, which fueled very high evaporative demand. But there are also contributing factors from a mildly dry fall, the record dry spring and summer, and an early meltout of our mountain snowpack. And this background image just shows the Wickiup Reservoir up near Bend in Deschutes County. And so it was one of the reservoirs that was the most impacted by the drought conditions in Eastern Oregon, Central and Eastern Oregon there. So one of the things that we do, and there's probably several of you on this call that participate in a Drought Monitor Advisory Committee for Oregon, and so you're probably very familiar with the U.S. Drought Monitor. So there's a national author that we give suggestions to every week on the drought status in Oregon. And these are the current conditions that the U.S. West is facing right now. And just a broad scale picture is that, as all of you know for sure, the U.S. West is in a historically significant droughts, not only this year but over the last several years, particularly, and also the last decade. We've been in some form of drought in the U.S. West, and the regions that are particularly hard hit are Eastern Washington, pretty much all Oregon, and then much of Idaho as well. So if we zoom into Oregon for current conditions, 72% of Oregon is either an extreme or exceptional drought, and these are the two worst drought categories. And in the drought monitor depiction, that's shown by these red color here for D3 or extreme drought, and then the dark red color shows the worst drought category, D4, exceptional drought. And the main message here is that much of the Klamath Basin, so Klamath and Lake counties, and then all through Central Oregon, east of the Cascade Crest, is in the exceptional drought. And also there's a patch here within Douglas and Lane counties that will probably be removed in a few weeks here. So those are the worst drought categories. And then much of the rest of the state obviously is in extreme drought. And Northwest Oregon is kind of been spared the worst drought conditions, and along the Cascade Crest as well. And if you look at just the time series of drought severity from the U.S. Drought Monitor, this just shows a 20-year record back to when the U.S. Drought Monitor started in the year 2000 of the percent area in each of these drought categories that is represented in the U.S. Drought Monitor. So besides the exceptional and extreme droughts, there's also a severe drought category, or D2, which is shown by the orangish color, and then moderate drought is the D1, or the tan color. And then yellow is not a drought category, but it just indicates the normally dry conditions. And So the take-home message here is that this is the most, this year has been the most extensive D3 and D4 coverage in U.S. drought monitor history, going back for the last 20 years. And so this is even more than back in the 2003 and 2004 drought, when pretty much the last time we had D4 conditions within the state of Oregon here. And you also see that there are a couple periods within the last 10 years where we've had multi-year droughts records. The most significant time being in 2014 and 2015, when much of the state was in extreme or D3 drought conditions. So how did we start off the water year 2020? So this shows the U.S. drought monitor depiction in October 6, 2020, at the start of the water year. And many of us had, you know, at that time we were going into moderate La Nina conditions, and we were kind of hoping that we were in store for a great winter and drought recovery going into it. So going into water year 2021, we had quite a bit of the state was in D3 or extreme droughts, and so this was mostly in central Oregon, parts of Lake and Harney counties, the Klamath Basin, of course, and then we had these D3 conditions that were spread up into the eastern Willamette Valley and into the central or north Oregon Cascade foothills. And we also had parts of the state that had no drought and were not abnormally dry. So this was in eastern Oregon, near the Wallowas and Blue Mountains, and then also in northwest Oregon, along the coast and in the coastal range here. So the drought was fairly severe last year, but it was definitely affected certain parts of the state much more than others. And as we got into progress through the year, so this just shows March 2nd, 2021. So if you all probably remember, this was a time when we had, you know, several atmospheric river events coming through in January and February, and you know, our average, you know, our precipitation statewide was looking much better, and you know, we were looking forward to, you know, a wet spring and stuff that would have really ameliorated a lot of the drought conditions throughout the state. And in the drought monitor, this was reflected by decreased coverage of extreme drought throughout the state, particularly in Western Oregon, where a lot of the D2, the extreme and the severe drought, was taken off the map. And we had, at that time, we had plentiful water. The North Oregon and Central Oregon Cascades had either normal or above normal snowpack. And so we were quite hopeful that going into the summer, you know, the drought was, you know, we were going to be well onto our way to drought recovery. Of course, we all know what happened next is that you know, we had a historically dry spring and summer. And what we ended up with, this just shows a map of the soil moisture content throughout the states that was basically current conditions right now. And this shows you that over most of the state, the soil moisture basically dried out through the spring and summer because of the lack of rainfall and high evaporation rates. And so we had went into the basically throughout the summer in historically dry conditions. And so this map, the red, so these are just showing the percentiles of the soil moisture content over about a meter depth of the soil column. And whoops. And this just shows that most of the state was in the lowest percentile range for this color map, and that that the soils were just near historic at record lows or near record lows throughout. And we can also see that in the stream flows as well. So not only was the soil really dry, but the watersheds that supplied stream flow were also really dry as well. The top panel here just shows over the last 45 days a time series of all the USGS streamflow gauges throughout Oregon, and the colors represent the number of gauges that were in various percentile classes. So the bright red here is the lowest percentile class or record low for those stream gauges. And so there are 111 sites that are included in this time series. And going into September, the middle of September, about 20% of the Oregon streamflow gauges were at record low streamflows. there. So that was really reflecting the very severe hydrological drought that we ended up coming up in throughout the year. About 40% of the streamflow gauges were at the lowest 10th percentile, 10th percentile, so it's near record lows. And then this brown color here is the bottom 25 percentile or bottom quartile here. And so about 2/3 of the gauges throughout the state were in the bottom 25% of historical stream flows here. So we were in extremely dry conditions that were reflected in both the stream flows and the soil moisture throughout. And this bottom panel just shows a time series going all the way back to about 2001, so for the last 20 years. And it just shows you kind of the same color scheme, but just kind of puts into context the stream flow record that we were experienced this year. And so this year we had 20% of our gauges at near record lows or at record lows. And so this rivaled the 2015 drought, which was mainly a snow drought, and it was greater than most other drought periods in this record here. So some of the impacts were felt, so that there's a wide variety of impacts that were felt this year from the droughts. And this, kind of a broad reflection of that is the number of drought declaration requests at the county level that we received this year in the Oregon Water Supply Availability and Drought Readiness Council that were forwarded to the governor and approved. So 25 out of 36 Oregon counties have so far received state level drought declarations this year. And we have one pending request that just came in from Curry County in southwest Oregon here. So this just kind of goes to show you some of the, and many of these drought declaration requests had severe impacts to both the agriculture and irrigation, livestock production, and municipal water quality and quantity as well. So what happened with this drought? We had this great snowpack coming into from starting in February. We had a great snowpack. And these four graphs just show a time series of this water year of basically an index of the snowpack in 4 different basins within Oregon. So we have the Hood, Sandy, Lower Deschutes on the northern Oregon Cascades, in the northern Oregon Cascades, the Rogue Umpqua, which is in the South Oregon Cascades, the Willamette Basin, which is in the Central Oregon Cascades, and then the Upper Deschutes and Crooked Basin, which is in Central Oregon here. And other than the Rogue and Umpqua, the Hoods, Willamette, and Deschutes basins came into April 1st with either average or above average snowpack. So the red trace here shows basically the amount of snow water in the snowpack at all the snowtail sites in that basin. And then this dashed line here is the median or normal snowpack that we typically encounter. And then the shading just shows various percentile ranges, just showing kind of the spread of all the various years in here. So we went into April with great, really good looking snowpack other than in the South Oregon Cascades. But what happened was that we started to warm up in April and May, some above average temperatures at higher elevations. And in most of these basins, we had an early meltout of 1 to 3 weeks early. So this was kind of a bad sign for water availability and stream flows come summertime here. So the early meltouts this year basically contributed to below average late summer stream flows, drier shallow groundwater systems in the higher elevation Cascades and in the foothills, and then a longer high elevation fire season, particularly in the South Oregon Cascades and some of the mountain ranges around there as well. So we had an earlier fire season that started in late June and early July, which was atypical for this time of year. So if you look at our total precipitation for the water year 2021, Oregon as a state averaged over the entire state, received about 80.7% of its average precipitation for water year 2021. And this is this number here is based on the PRISM precipitation analysis. So if you rely on statistics from like NCI or maybe some other station type data, this number can be slightly different, but they're all pretty close to this. So going back to 1895, this water year ranks as the 16th lowest total precipitation out of 127 years. So, that's pretty bad. So it was pretty poor water input into Oregon. And I just put together this table here just showing how 2021 ranks against other water years here. So the driest water year that Oregon has ever received was in 1977, where we only had 60% of average precipitation. And what's kind of interesting is last year, in water year 2020, we actually had slightly less precipitation than we did this year. And the only other two records that, or three records that any of us might have been around for was the water year 2005, which we just eked out. And then also in 1992, which was number 11 on the table. So some of you may remember the 1992 drought in the US West. So even though, this wasn't the worst drought by just raw precipitation statistics. So as I'm going to go through a little bit here, this water didn't go as far as it usually does in other years. And this is due to actually much higher evaporative losses, as we'll cover next here. But first I wanted to go into just the county precipitation rankings, because this kind of tells a story about the geographical distribution of the dryness that we experience in Oregon. And so if you look at the whole water year and then just look at the county levels, most of the counties within Central Oregon and Central and Southern Oregon were in the were below ranked below the 10th driest year all time as far as precipitation goes. So this was Klamath County, Lake County, Deschutes. Crook County was especially problematic. It was its 4th driest all time. And then Grant County and Wheeler County here, and Morrow County here. And then also kind of surprisingly was, I thought was Wallowa County up in the far northeast Oregon was its 11th driest all time, which is a little bit concerning because the Wallowas actually had a fairly decent snowpack and had received a few pretty good doses of rain from various atmospheric river events. So this was kind of a bit surprising area here. In Western Oregon, it actually wasn't so bad. We were kind of in the bottom third for the most part of water years going back to 1895 in Western Oregon here. So Western Oregon, at least for the entire water year, didn't fare too badly. And if you just look at this, going back to the statewide precipitation again, this is just the time series of monthly values for the last 2 years. So the black curve here just shows the median of values going back to 1895, and then the shading just shows the percentile ranges of the various water years. And then the red X's show our monthly values for 2021 on the right half of the graph, and then 2020 on the left half here. And it was really nice to see in September that we ended up well above normal for our September precipitation. So this is a good start to drought recovery in water year 2022. But going back, you could see that all the last 6 months before that were much drier than normal going into the spring. And then we had January and February in Oregon were either normal or slightly or above normal. So these were due to those 2 atmospheric river events. And then November 2020 was pretty good. But overall, 17 out of the last 24 months were below average precipitation statewide. So this was kind of definitely indicative of the multi-year aspect of this drought. As far as so our drought was made particularly severe by the poor precipitation we received during the spring and summer. And in the last several years, we've relied on kind of above average precipitation during the springtime to make up water deficits that we accrued either during the fall or winter. And we were very much hoping for that this year again. and that didn't happen at all. So Oregon endured its second driest 7-month period ending in September, so March through September, on record. And we just barely missed out on first place, which was in 1924. So again, we came into the spring with the ongoing droughts, and we really needed a good spring and summer rainfall to kind of recover, to continue our recovery from it, and that didn't happen at all. So basically everywhere, nearly everywhere in the state recorded, you know, in the top 5 or 10 driest spring and summer on record. So this just shows the county rankings for the 7-month period between March and September 2021. And the hardest hit areas were basically in the northern and central Oregon, and then also a lot of western Oregon as well. The only places that, you know, were dry but not quite so dry were over in Malheur County, particularly around the Oahe Mountains area in the kind of the central and eastern Malheur County, and then also down into Curry and Coos County here. But several of the counties in the northern part here were either the driest or second driest on record, including Grant, Umatilla, Morrow, and Shoreman counties here. So so this was really kind of a very worrying part, because many of these counties were already in either severe or extreme drought conditions going into this time period. So that was on the rainfall side. What about the evaporation side? So basically, because we had such a warm year, and particularly a warm summer, there was a much greater evaporative demand than normal, and so this pulls water out of the landscape and dries things out much quicker. And so this basically means that the precipitation we did receive didn't go as far as it usually does. And so one statistic that or drought index that we use to monitor evaporative demand loss is called the Evaporative Demand Drought Index, or the EDDI. And so this provides an estimate of this evaporative demand or evaporative loss of water given a certain surface water balance. So it's dependent mainly on the air temperature and specific humidity near the surface, but it also depends on wind speed, radiation, and atmospheric moisture. And so if you look at the going in middle of September and then the preceding 6 months, these colors basically show the relative EDDI, relative to historical conditions, and gives you kind of a percentile ranking. So the reds are in the bottom, 5% of evaporation, and then the dark reds are the bottom 2%. So that's at or near record lows. And so much of Oregon, you can see in the 6 months going into September, had experienced record or near record evaporative loss from the landscape. The exception was kind of in Malheur County in eastern Oregon down here. And if you look at the entire water year, really the evaporative demands, the water year, we had much more evaporation than normal. And the worst hit areas are the most, where the drought was the most intense entering this water year. So in central Oregon, and then in southwest Oregon down here. So, one of the droughts, so basically trying to assess the drought severity in Oregon, we have to account for both the precipitation, so the input of water, and then the loss of water through evaporation. And one of the primary drought metrics that we use to do this, and that we use, the Drought Monitor uses, is called the Palmer Drought Severity Index, or the PDSI. And so this essentially incorporates both precipitation and temperature on water supply in the landscape. And it's derived from a moisture balance model, and it uses historical meteorological records that are commonly available. And then it makes some assumptions on the water capacity of the soil, and et cetera here. And for the Palmer Drought Severity Index for August 2021 was at -5.2. So negative numbers in the PDSI indicate drought conditions, and positive numbers indicate not drought conditions or wet periods. And so the -5.2 was the second lowest monthly ranking in the last 127 years. So at least by this measure, it suggests that the drought was probably the second worst in record, and the lowest PDSI occurred in April of 1977, down here, the 1977 drought. So this metric definitely suggests that this drought was one of the worst that we had experienced in the state. So actually the updated PDSI for September 2021 improved to -4.44, which is the 12th lowest monthly ranking on record. And it improved because of that nice little wet period that we got in mid to late September that kind of started to improve the drought conditions in some parts of the state. So at least I'm trying to get at the looking at the PDSI and trying to equate that to various drought categories in the U.S. Drought Monitor. I just showed a table here that we use as guidance for equating ranges of the PDSI with categories in the U.S. Drought Monitor. And so you could see that anything below -5 is the worst drought category or exceptional drought, and anything between -4 and -5 is the extreme drought category. So in August, the state as a whole was in exceptional drought category, at least according to this metric. And in September, we improved to the extreme drought category, or D3, by this metric here. So that was a statewide look. So you can actually go to a little bit more granular level of looking at the different climate divisions in Oregon and looking at how the PDSI ranked in the historical data record in August 2021. And in that case, we had several of our climate divisions had the worst the worst PDSI on record out of the 127 years. So this includes a big swath of Western and Central Oregon, and then also in Northern Oregon here, which was actually quite surprising. The Willamette climate division, which is this one that encompasses the Willamette Valley and the surrounding foothills up to the, getting close to the Cascade Crest, was its driest by this metric that we had ever seen before, which was actually kind of surprising because going into this, I kind of thought that the Willamette Valley, especially the northern part, was faring a little bit better than other parts of the state, but that evidently wasn't true here. And then Malheur County was looked the best here, even though we had quite severe drought impacts in Malheur County. At least by the PDSI, it didn't seem so bad here. And then there's this broad region here of the Central Oregon Climate Division, which is the second worst PDSI record, and the first worst, of course, was 1977 here. But the Coastal Division didn't do too badly, but it was still the fourth lowest PDSI in record. We also assessed drought using another drought metric called the Standardized Precipitation and Evapotranspiration Index, and it's also commonly used in the U.S. Drought Monitor. And so it provides kind of another estimate of drought severity that we'd like to use. And the SPI actually correlates better with stream flow conditions, lake levels, and things like that. So it's actually probably a slightly more useful drought indicator for assessing hydrological drought conditions. And by hydrological drought, I mean the amount of water that's in the groundwater systems and in lakes and surface water here. So if we look at the 6 months SPI, so the SPI over the last 6 months, this actually suggests that our summer and spring was the worst on record in Oregon statewide. So much worse than 1977 and a couple of the drought periods in the 1920s and 1930s. And so this actually agrees with a lot of the stream flow gauges that we were monitoring during the summer, especially the mid to late summer, that were setting all-time record flow lows or low flows in many parts of the state, particularly in Southwest and Central Oregon. So one thing I want to say about the SPI was that it also incorporates evaporation or evapotranspiration in deriving a net surface water balance. So this is better than just looking at straight precipitation or straight precipitation anomalies or deficits or something like that, because it incorporates the evaporative losses that are affecting the drought conditions here. So if we go out to a longer year and just look at the water year in total, the 2020 water year 2021 is ranked as the 6th driest on record. And so it wasn't the worst if you consider the entire year. And one of the things that really saved us in terms of this drought metric was the wet January and February that we had in 2021, and the kind of the improvements to the snowpack that made. One thing I want to point out here is over the last 22 years, 16 years out of the last 22 years had an SPI, a water year SPI that was well below 0. So by this metric, it would suggest that 16 out of the last 22 years in Oregon was in some form of drought, including many consecutive years of drought, especially between 2012 and 2017, and then the last 3 out of the last 4 years as well here. And if you want to go back, you can actually go back with this metric out to 24 months. And doing so for the last 2 water years and looking at this metric going back in time, the water year 2020 and 2021 had the 2nd lowest 2-year SPI on record, second only to the 1930 and 1931 drought periods here. So this was definitely one of the most severe multi-year droughts that we've experienced, and so that was kind of explains why a lot of the drought impacts that we received this year were so much worse than during water year 2020. And so what caused the evaporative loss to be so high throughout the landscape? And it was basically the record warm summer that we had. And so this was just a time series of the summer temperature, average temperature, going back to 1895. And so this is the 3 months ending in August. So this is June, July, and August, average temperature. So we recorded, at least through this data set, oops, I'm sorry, I keep doing that. Through this data set, our average temperature was 67.5 degrees Fahrenheit. And so it's slightly different than other precipitation analysis, but that's the number for this one. It's a pretty trustworthy number. And it was 4.8 degrees above normal, and way above normal than any other, or way above any of the other summers on record here, even warmer than the summer of 2015, which was the previous record here. So this was a big factor in the enhanced evaporative loss that we experienced throughout the spring and summer here. And so this shows a county rank. So it just shows you where the warmest temperatures, or the most anomalous temperatures were throughout the state. And so it was mostly in southern and central Oregon, experienced their warmest summer on record. Umatilla County also, and then basically most other counties were in the top 10 or top 7 of their driest or their warmest 6-month period temperatures on record, so between March and September here. And then if we just zoom in on summer here, sorry about that, I meant to take the last slide out. This is the summer ranking, June, July, and August here. Most counties, all counties either experienced their warmest or second warmest summer on record, which is, and these were the worst counties because this is where the drought was most severe in terms of precipitation here. And it was, so the warm summer, the record warm summer wasn't just a product of the June heat wave, even though that was definitely a contributing factor, but we also had these prolonged stretches of well above average temperatures. And one way to look at it is looking at the number of days that are greater than equal to 90 degrees Fahrenheit. And I've seen on social media that all the Weather Service offices have been keeping track of this. So I got this data through NCI, and I last accessed it on September 14th. So I think especially Medford there has a few more 90-degree days. But this is the list right here and where it ranks in the all-time temperature records here. So, many of the station records in these towns indicated that they had, either the most 90-degree days on record or near the most, second place here, especially in, Willamette Valley and Salem and Eugene, but also down in Klamath Falls, in Burns in Eastern Oregon, Bend and Redmond. And Medford here was a little bit of an outlier in that this was only the 14th most number of 90-degree days. And I think this had to do with the fact that they were kind of clogged in with smoke a lot of days. And so it kind of limited the afternoon high temperatures in August, particularly in August, but also in late July too. So without that smoke, we probably would have had, a near record number of 90-degree days as well here. So the main point here is that we just had many prolonged stretches of, well above average temperature, which just cooked the landscape and took all the water out of it. So finally, I want to end with, or I guess it's not quite the end, but I want to take a look at the current SPEI. So this was as of a couple of days ago. And this map shows colors between 2 and -2. So recall that the SPI, when we get to negative numbers here, or the orange colors, it basically indicates conditions that are consistent with drought. And so the whole state still has very low SPI, especially in these drought regions here. So an SPI value of -2 is consistent with D4 drought conditions, or the exceptional drought conditions. And then the SPI of about -1.6 to -2 corresponds to the extreme drought conditions, or D3. So much of the state is still in either D3 or D4 levels according to this. Although we're starting to get some improvements along the coast, down in Curry and Coos County. In Northwest Oregon, a few weeks ago, we were getting close to -2 up in this area, but our recent rain events have kind of started to chip away at this drought indicator a little bit. If you go out to 365 days, we're starting to look a little better. In this case, particularly in Western Oregon, we're starting not to see quite as bad drought conditions, so it's getting closer to neutral, which is between -0.5 and 0.5 in some parts of the coast here. So this is one of the drought indicators that we really look at when we're making suggestions on U.S. Drought Monitor conditions. And so we all get asked a lot about, how good of a wet season do we need to kind of recover from drought conditions? And so there's this really cool experimental online tool through NOAA. It's called a drought amelioration tool. And so many of you probably have heard of this or have seen it, but if not, I just thought I'd show it real quick. And basically it tries to answer the question is, so if we take one of these drought indicators and then we rain a lot on Oregon, how much rain do we need to improve that drought indicator to non-drought conditions? And so the drought indicator they choose is what's called the Palmer Hydrological Drought Index, and it's actually very similar to the PDSI that I'd shown earlier. There are some differences, but I'm not going to go into it here. And it basically makes some assumptions on temperature and soil conditions and whatever. But it basically says how much rain do you need to get the PHDI or the PDSI to be greater than -0.5, which is the threshold for moderate drought. It's a threshold for drought. And then you could choose a time period in which that you would have a wet season for. So in this case, I chose 6 months. So it'd go between October through the end of next March. So basically to April 1st. And it says, how much rain do you need by April 1st to basically get us out of drought? And in Western Oregon, the answer is somewhere between 118% and 126% of average is what we need precipitation-wise. And in Eastern Oregon, the numbers are between 128% in Malheur County and about 140 to 158% in the rest of Eastern and Central Oregon here. And so these numbers actually seem fairly reasonable. Like if you were to just kind of guess about how much rain we would need, you know, kind of based on other things, these kind of numbers would kind of, you know, these numbers sound pretty reasonable for that. So this is precipitation isn't the only factor you consider in, you know, in setting like drought categories in the U.S. Drought Monitor, but it is, you know, obviously a very important one because it correlates well with stream flow and soil moisture and snowpack and things like that. So these are kind of numbers when I get asked that I try to quote for people here. So I'd be interested in, you know, what the Weather Service offices are thinking about in terms of this as well. So finally, I just had a couple random thoughts on the Oregon drought severity for water year 2021. And as a wrap up, so this was the second year of a multi-year drought. And I think it's very important to consider this as a multi-year drought because the impacts kind of compound each consecutive year that we're in drought. And we really found that this year because we had low carryover in a lot of the reservoirs. We had soil moisture deficits, groundwater deficits that were built up from last year that carried over to this year and then were made much worse. So the drought metrics pretty much show that this drought severity was, made much more severe on the medium term, so between spring and summer in 2021. So this character of this drought was affected by the early snow meltout because the stream flows really tanked in June when we'd be expecting a lot of runoff from snow melt. And by that point, all the snow had ran off and had already flushed through the system. And so we were kind of left with our summer base flows starting in early July. Stream flows and soil moisture set records lows for most of the summer statewide. So there really was no part of the state that was unaffected by that. The drought impacts this year were more severe compared with last year, particularly with the agricultural sector, but also a number of other sectors. We had, fish die-offs, water quality issues, dry wells, and the list goes on and on. But we definitely saw much more compared to last year. And finally, the last slide I had was the precipitation was not going as far as it used to due to rising temperatures and evaporation. And we really are seeing this now. And so characterizing droughts based solely on precipitation deficits is not, I don't think, a fair characterization of drought severity and extent. So anyway, that's all I had. So I'd love to take any questions or have any discussion that you guys would like. Thank you.
Larry, this is Andy. Can you hear me?
Yeah. Hi, Andy.
Hi. I was just finally able to get in. I was unsuccessful getting in as the organizer. So thanks to Trina Jensen, our warning coordination meteorologist, for being the organizer in my stead. So what Trina's going to do right now is unmute everybody. I think there's about 25 people on the I keep getting muted and then unmuted, so hopefully you guys can still hear me. If you have a question for Larry, I was gonna say if you wanna just jump in with that. If you don't have a question, then just mute yourself. So does anybody out there?
Hey, hey, Larry, this is Ryan Sandler down at the Medford office. That's a neat tool that you showed us at the end, the current drought reduction tool. Yeah. Boy, in my head, I thought it's going to take way more than that, just because the reservoirs are so low. I've seen like Lake Shasta fill in one good season where it was not as low as it is now, but it was really low, and so there's some hope there. But boy, I've never seen our reservoirs this low. So I in my brain, I just thought we're going to need like a near record type winter to get out of this drought. I hope that's wrong, and I hope that this tool is closer to the truth. Not really a question.
No, actually, the feedback is really good, because I also suspect that this is under like lowballing it by quite a bit. And so this only just takes a drought indicator. It doesn't take into account basically the groundwater conditions or the reservoir conditions and stored groundwater. And I think you're absolutely right. I think it's going to be kind of several years to recover. And but it is interesting to think about what it would take to at least move those drought indicators. And from a drought monitor perspective, or drought monitoring perspective, those drought indicators are relied on heavily for setting the drought categories. And so if we do get close to this, we might the reservoirs aren't going to be full, or probably not going to be full, filled by just this amount of water. And so this is where we'll have to fight with the national authors on the drought monitor to kind of set more realistic drought categories based on actual surface water supply.
Right. Okay. Thank you.
Yeah.
Anybody else have a question or a thought for Larry? This is Andy. I'll just echo Ryan's thoughts about the reservoir storage. On our state coordination call this week, hearing from John Roca at the Bureau of Reclamation, there are several reservoirs around the state that are at or near record low carryover storage. So I think that's a factor that isn't really accounted for in a lot of the drought indices that we look at, as we make assessments on where we are and how things are changing. So like Larry said, that's something for all of us to be cognizant of as we go through the winter and the spring. And I guess I'd be curious about other folks' thoughts out there as to what is your time horizon that you're looking for to see, like, when will you feel comfortable making an assessment that, hey, I think we're out of this drought? Anybody have thoughts on that out there?
Yeah, I would say that the time scale of recovery is really important. It's not very well known. It depends regionally, on soil types and stream flow conditions, what the snowpack does, the usage within the water usage, the management of the water usage. And it's really hard on the Drought Monitor Advisory Committee for us to, we make guesses and assessments and stuff, but it's really hard to communicate that with the national authors. And we struggle with that. I don't know if that's your experience, Andy, too.
Well, I think the national authors are certainly happy to listen to us. I think a lot of this, we're trying to figure out ourselves, and so sometimes it's hard to know what is reasonable input to provide to them. But for me, I really want to see, I think based on what we saw this year, and knowing how dependent we are on spring precipitation, I don't want to get too aggressive with drought monitor improvements until we get through both the winter and the spring. And let's see where we are as we get into really the demand period for both irrigation from natural stream flow and from managed rivers. Anybody else have a question or a comment for Larry? Or thoughts about impacts that you're seeing in your region of the state?
Well, this is Ryan again in Medford. The impacts are devastating down here. The Talon Irrigation District had about 2 weeks of water of irrigation. And you're talking about thousands of acres of farms. We know the Klamath Basin is just a mess. Even in an average year, it's a bit of a problem. it was just like nothing growing compared to normal. They're taking out a lot of pear orchards, and it's not the only reason, but it's kind of the last nail in the coffin down here for a lot of the pear orchards that have been here about 110 to 120 years. So yeah, things are going to change over the next 5 to 10 years in this region as far as what they're growing and how many acres will be used for agriculture. That's it.
Thanks, Ryan.
Yeah.
Hey, Andy, Larry, this is Dan at the Portland office. Can you guys hear me okay?
Yes.
Yes.
Quick question. The that you still have up here, the percent of normal needed to end drought conditions. Do you have the web where that page can be accessed?
Yes. I don't know if I put it in the chat, if it will go to you or not. Let me try it.
The other thing is we can email this out to everybody because I think it is a really interesting tool to look at.
Okay, let's do that. I'll send it to you, and then is that okay?
That's great. Yep.
That's fine. Thank you.
Yeah. Yeah, I use this tool with, there's another online tool that also goes back and gives basically through the historical precipitation records and gives you the percent chance of meeting this number. So I ran the numbers for a couple places throughout the state, but in Salem, for instance, the chance of getting 122% average over this 6-month period was something like 23%. So, there was it's hard to know, people are asking you to give kind of an answer for, what kind of winter we need for, to improve the drought. And, this kind of gives you kind of a guess that's, maybe not the best guess, but maybe it's the best that we can provide based on conditions.
Well, Larry, thank you for taking the time and for not applying the 10-minute rule. I remember when I was way back in school, if the teacher didn't show up within 10 minutes of the start of the class, then you kind of figured that the class is canceled. So thanks for sticking around. And Trina, if you can go ahead and stop the recording, and we will be sending out information on how to get to the recording. We'll work that out and make that available so that other people in Weather Service offices can have a listen and a view to what was presented today. And if you think of other questions for Larry, feel free to reach out to him at Oregon State, and I'll pass along info, like the link that was just mentioned. So thanks everybody for being here today, and hopefully you got some new insight into the crazy conditions we've had over the past several months, and we will call it a wrap on this webinar. So
Yeah,
Trina, feel free to end things for us. Thanks everybody.
Thank you.
thanks.